In this video, you will be presented with an overview of a .NET Azure App Service Diagnose and Solve Problems Generated .NET Profiler Trace report, which was captured to diagnose a high CPU issue. Additionally, the manual analysis of the same trace using PerView on your local machine is provided. It is expected that you have already downloaded the .NET Profiler Trace and PerView. A link to the video showing how to capture this .NET Profiler trace is provided in the description below, as is a link to the official PerView download GitHub repository. Select the web link icon next to the instance name to open the .NET Profiler Trace analysis report. Notice the breakdown of time spent in request execution between application code, platform, and network. Notice the list of slowest requests. Navigate through the different tabs and analyze the findings. For example, .NET Core slow requests, failed requests, thread call stacks, .NET extensions, and CPU stacks. Click the CPU Stacks tab and click the Stack button. You can see specifically what is going on. The module named C#guitar.dll. There is a page named High CPU Hang, which appears to be the culprit, and it's utilizing a regular expression. Provide this input to the party owning this assembly and have them investigate the code. To analyze the .NET Profiler trace locally, open the .diag session file in PerView. Double-click the .diag session file. It will take a few moments to load, so please be patient. Once loaded, double-click or expand the diag session file to expose the ETL file. Double-click CPU stacks. Notice that the W3WP process has the highest CPU MSEC value. Therefore, it has the highest amount of interest. Double-click the W3WP process. Select the Call Tree tab. Notice that the threads are ordered by inc%, which identifies how much resource is being consumed by this thread. Check the thread checkbox with the highest inc%. Check the thread checkbox with the highest inc%. Then navigate into the modules check by check until you reach the non-Microsoft assembly, which is the root cause of the problem. Provide this input to the party owning this assembly and have them investigate the code. And finally, but extremely important, is to recognize that memory dumps and .NET traces contain very sensitive information. Take extreme precautions and follow documented procedures for the handling of these files. Remove them from all devices once they are no longer needed.